Hey, Amit.
Hey, though.
Hi. So Amit and I just got off the webinar. Amit, how do you think it went?
Went very well. We had a lot of people on the webinar. We went through the creating a separate staging environment, looking like create and run a notebook using it for the demo purpose, where you can create a separate environment, a staging environment from your production without even copying the data. And then you can do your testing. And once you are ready, if you are done, you can promote that to production atomically. So that's what we covered in the demo.
Yeah, awesome. I think that it's worth mentioning a few things as takeaways from this webinar. One, if anybody wants to spin up a lakeFS playground environment and play with lakeFS, that's a good option. Two, all the notebook that we went through today are available here in the middle scan and the webinar sample where you can go and show how we create that sample, that staging environment, make changes, and atomically promote everything to production. And lastly, if anybody wants to kind of look at the hooks usage from start to finish, including an example here that forces file format in a CI/CD pipeline, we have that example as well. We're going to play the recording of the webinar right now. Really appreciate everybody's time. And if anybody has questions, feel free to reach out on Slack or any other format. Amit, thank you again. It was fun.
Thank you.
Okay, have fun, everybody. Bye-bye.
Bye-bye.
Okay, for those of you that joined, thank you. I still see people jumping in, but I think we should start because we're already 1 minute past. So, hi, everybody. I'm Ido. I run customer success with lakeFS, and with me today is Amit. Hi, Amit.
Hey, Ido.
So before we start, just a few, I guess, housekeeping things. Everybody here is anonymous, so we don't share the people's name. If you have questions, you are very welcome to ask them using the Q&A button that you see in front of you. We will answer those either live or on the chat as you ask those questions. Keep in mind that you can ask the questions either anonymously or with your name. And if you ask them with your name, then everybody will see your name come up. Today, Amit and I are going to talk about promoting only high quality data to production. I see some familiar names. I see some unfamiliar names. So I am wondering, before we start, I don't know, Ankit, if this is something that we can do. Can we ask differently? Can we first ask how many people here heard of lakeFS before, so we'll know that we're asking the right content? Yeah, so if you guys could just answer that, so we'll know if we want to go in details or not go into details. That would be great. That's as this comes up. Thank you. For those of you, I think that this is a question for those of you who are in the Zoom, not for those of you that are on other medias like LinkedIn and things like that. So if you do, you can just ask questions over there and we'll send them over here. What do we mean by promoting high quality data to production? Let's talk about promoting to production in general. So it seems like we do this very differently between code and data. I'll explain. When we want to make a change in production, in the code that's running in production, typically what we do is we create a copy or a branch of the production code, the entire code base, so we can develop against it. We develop it, we test it, and then when we're about to put it into production, there's usually a pre-prod or a staging or an acceptance or a UAT, whatever you want to call it, environment where we deploy the new code into there, make sure that it plays nicely with everything else. And then there will be some sort of promotion into production once we are 100% sure that this is working in pre-prod. And of course, this is not just for one person, but this can be a lot of developers that make a lot of changes to a lot of areas in the code at the same time. Now, what we found out is that it turns out this is very different in the world of data. So you have production data, right? You already have a data lake of some sort where you keep data. And typically the first thing you want to do when you want to, for example, work on a new ETL is you'll sample or you copy the data somewhere on the side to develop something. Then you will test against that sample data. And now I have an ETL that I like and I'm happy with and it's okay. So I'm going to take the code that I created, I'm going to modify it a little bit, not to point to that development bucket, but to point to my production bucket. And then I will run my code against production in reality for the first time against production. That's how we operate. That's what the industry is giving us so far. Now, Amit, you've been doing this for, I don't want to embarrass you, but you've been doing this for a couple of decades now as data engineering. Is this kind of a good representation of what's going on?
Yeah, that's the correct representation. And the challenge with this is things break in production. You run the code and things will go down and your users will start screaming.
Oh yeah, that's fun. It's always fun to troubleshoot under fire, sorry, or water. So yeah, so here comes lakeFS, and we said let's do this differently. Let's manage the data the same way as we manage code, and we built something that you can spin up in 20 minutes or so, which basically sits on top of. And I'm going briefly over this because it looks like many, though not all, of the people here have heard of lakeFS before, and then we'll go to the demo. lakeFS sits on top of the object store and gives Git-like capabilities for object store, merge, commit, branch, revert to an API. So the ecosystem of tools that we have running in our system can either access the object store regularly or through lakeFS and get those Git capabilities. And to make this a very simple integration, what we did is also from a use perspective, if before we were accessing a collection in a bucket, now we're accessing a branch name such as prod or stage, or a commit identifier such as prod before we ran the ETL yesterday at 3 p.m. or prod after we ran the ETL yesterday at 4 p.m., assuming that we committed both these points of time, or we have something that automatically commits those. And then the Git actions themselves can be done through an API or through a web user interface or through a command line, and we'll show those throughout the demo here shortly. And the idea is to be able to achieve CI/CD for your data, right? So the way that our users use lakeFS is, if I need to run a transformation, I will branch out, I will run the multi-step transformation, and then I will merge back into lakeFS. And this is where it becomes to production. And this is where it becomes interesting. This becomes my staging environment, right? I run my ETL, I make sure that there's no problem with bad data, missing columns, whatever, something that went down, that it can complete holistically on all the changes that I make. And when I merge it, I can run a pre-merge quality checks. lakeFS has hooks, similar to Git action, pre-merge, post-commit, pre-branch, post-branch, pre-merge, post-merge, right? Where I can actually run quality checks. For example, I can make sure that I never input a specific file format, I never merge it into production, or any code that I want to do to, every day I get 50 new records, today I got 5,000 new records, maybe there's something wrong there. And we'll walk in this webinar through how to set this up. With that, I'll hand it over to you, Amit.
Oh, thank you. So let me share my screen. 1 second. Let me hide my, okay, thank you. So for the demo today, or kind of workshop, there are 2 prerequisites. One is to have Docker running on your local environment. So I'm running Docker on my laptop. So we'll run the few containers for this demo. And also sign up to the lakeFS. You need a lakeFS server for this workshop. You can go to lakeFS Playground, the demo environment, and sign up. And within a few seconds, once you sign up, like you'll go to this demo environment here, sign up for the playground. Once you sign up, you will receive an email in about 10-15 seconds with your credentials to log into lakeFS playground. This is in our cloud environment, so you don't have to install anything, just sign up and you'll have the running lakeFS server. So you receive an email like this, where it will have a link to connect to your lakeFS playground. So when you click on that, it will give you the URL, which will point to the playground. So let's click on this. So this is my lakeFS playground environment, just for dedicated to me, and nobody else is using that one. Then I need these credentials to log in to my lakeFS playground. So let's copy this access key and then get my credentials key. And this playground will be available for 7 days. So once you log into this playground, there will be by default, there's a my repo created. This is like a similar kind of interface as familiar with Git. So you will have a my repo, and which points to a S3 storage bucket that we are providing along with this playground. So you don't need to have your own storage S3 bucket. In this case, we are providing everything in the playground. And here you can create multiple repositories. So in this demo, I'm going to create additional repository also. So, but this is the existing one with some examples, samples, notebook, etc. So let's go back here.
So Amit, I think in this demo, we're going to use mostly Spark, right?
Correct. So we'll use the Spark notebook with the Spark integration. So that's also next we're going to clone that. So we provide awesome. A Git repository which has that is Spark notebook with the Spark integration.
So yeah, so it might be interesting. It might be a good point, because I forgot to ask before, to kind of ask the team what's their technology stack for the people that are on over here as well. If you guys can take a chance, you can a second, just so we reference the right things on this call as well. You can choose more than one option, of course. Thank you, and sorry for the disruption.
Oh, no worries. Good to know that. Yeah. So next, so far what I have done, like I set up the playground, sign up for the playground, received an email, and then log into the playground. The next thing is to clone the Git repository. So we'll provide you all those links, so you don't have to worry about this. So once you go to this samples repo, we are going to use this sample repo number 3, which is Spark and Python demo. So here it provides you the instructions. I already mentioned about the prerequisites, so we are good with that. And next is clone this Git repository and then run this as a container in a Docker environment. So I already cloned this repo. It takes a few seconds to clone it. So I already have this lakeFS samples repository cloned. Next, go to this. I'll change this to the particular folder structure here. And then run this command to build the container and run the container. So the whole demo, everything is packaged into a single container. When you run this, when you build this container for the first time, it might take about 5-10 minutes to download all the required images. I already did this earlier, so I have all the required images here. So it went very fast. So once you run this, you'll see there's this container running here. It's called lakeFS Spark Python demo container. So the whole notebook and Spark and Python, everything is packaged in a single container. So let's go back here. So now my setup is done. So I did initial setup, log into the playground or sign up for the playground and log in, and also now clone the repository, this demo repository, and run the containers. So let's start the demo now. So for this, in this container, we also have a Jupyter lab running or Jupyter notebook. So when you click on this, when you're running locally, it will be pointing to this IP address or local host and the port number. So if you click on that, it will take you to the Jupyter Lab UI. And with this container, we have multiple demos already bundled. So for today's presentation for workshop, we are going to use this Spark demo, but there are Delta Lake demo, Airflow, and multiple other demos. You can find more information about this in the repo. Okay, so let's look into the Spark demo. So for this, what we are going to do is set up a repository from scratch, load some files into the repository, and create the kind of main production kind of environment. And then we'll do the kind of staging environment for experimentation or testing purpose. We'll create a new branch from production and then run our kind of, let's say, ETL code in the separate branch, not impacting the production branch. And then we'll, once we are satisfied that ETL job works fine, or experimentation succeeds, then we'll merge that all the data files into production branch. And if something goes wrong in the production branch, let's say we merge the changes into production, but there's something wrong, we need to revert back the changes, we'll roll back also the changes. And we'll also show the hooks, how the hooks work. So that's kind of high level on the what I'm going to show in the demo. So next thing is here in this notebook, set up lakeFS credentials in a variable, which we'll use further on. So let's get the lakeFS endpoint. So again, go back to your playground sign up and then get the lakeFS endpoint here. So let's copy this. Next
so
thing
the
I
playground represents, sorry.
Yeah.
So the playground represents a lakeFS server. You can use the playground, or you can, of course, spin up lakeFS internally, or you can use lakeFS cloud, but this is the lakeFS server. And then the other part is just the way that the other notebook and package container that we download is ways to use against lakeFS server to show how to atomically promote high quality data to production, right?
That is correct. So next copy the credentials information. So let's get access key and change it here in this notebook. Let's get the secret key. And also we need the storage namespace information. I'm going to create the new repository. So what we can do, you can use this existing storage namespace and add your repo name or another folder structure within that. So let me call this my repo. So those are the settings you have to change, all the variable information that you have to change. So first the credentials. So let's run this cell, and then let's define the variable for storage namespace. The next thing is the versioning information. So when I create a new repository, I'm going to use main as my production branch. You can call it master. Some people call it master. Some people use production branch. So whatever you want to call your main production branch, you can define as a variable here. And then I'm going to, once my production branch is ready, I'm going to create a new branch for experimentation purpose, where you can run your ETL code or whatever experiment you're running without impacting your production main branch. And in this example, I'm going to use a CSV file, which is also bundled along with in this container. So anything required for this demo is packaged together in this container. And then we are going to do partitioning some data in the experimentation branch. So I'll go through that next. So let's define my versioning information. Next thing, I'm going to use the lakeFS Python client to interact from this notebook. So the Python client requires the access keys and the endpoint to connect to the lakeFS server. So that's what I set up here and create the lakeFS client, which we'll use further. And again, everything is packaged here, so you don't have to install anything on your own. Next, give the repo name. So let's say instead of my repo, I'm going to create a new repo called Amit repo. So let's set up that as a variable name. So next thing, you can create the repo from using the API. So that's what I'm going to do. But if you want, you can also create the repository from the UI. So same thing, instead of doing from the UI, I'm going to do this from the Python client API. So if you see here, I'm using this client, which I created earlier, and just calling this repositories create repository API. So now I got the new repository created. So if I go back and refresh this page, so now I have my repo, a new repo, again, using the storage namespace, which was provided to me with this playground, and added my repo name here as a folder structure. So right now the repository is blank. There's nothing in there, just the main branch, which I used when I created the repository. You can call it master or production. Next thing, we are going to set up this production environment. So for this demo purpose, I'm just going to upload a single file, a CSV file. But if you want to do your own testing, you can upload additional objects. You can do through the API, or you can do from the UI here, and which you can select any files you have locally, you can select and upload into your repository. So for this demo here, I'm going to use this upload object API and uploading a CSV file, which is packaged in this container. So this is,
and of course, if someone wants to get started with lakeFS, do we have to copy files, or is there a quick other way to get started?
Yeah, so quick way, if you have, let's say if you have existing data lake and you want to bring that into lakeFS, you can do the import. Import is different from the upload. Import just imports the metadata about your data lake or the object file. So let's say you have terabytes of files, a petabyte of files in your lakeFS. We are not going to copy those files. We are just going to bring only the metadata or pointers to those files. So like, for example, in this case, if I import this one, right now I can't do from here, but yeah, I don't have access. But normally when you do, it will just import the files that, the metadata for those files, not the actual data.
Awesome.
So going back here, so now I uploaded a file into my main branch, and let me commit this change. So if I go back to my repo and the main branch and refresh this, so now I have this CSV file. Again, you can upload as many files as you want. Next thing, I'm going to use S3 gateway to interact from Spark to lakeFS. There are two options available. One is S3 gateway, which a lot of people already know about. So that's what we are using here in the demo. But we also provide a lakeFS client that you can use to interact from Spark to lakeFS, which is kind of lakeFS, its own Hadoop file system instead of using S3 gateway. But for this demo, let's continue with S3 gateway, and let's configure that. So in this case, just setting up the access key and credentials to connect to the lakeFS. And now just to make sure this gateway, S3 gateway is working, we are going to read the file we just uploaded earlier, the CSV file. So here, when you read from using the S3 gateway, you specify the repo name and the branch name.
Yeah, so when we got started here, right, we set up lakeFS server with the playground. That was step one, which you can, again, set up lakeFS server in some other ways that are written here as well. And then we did some things that got around this notebook, but this gateway configuration is what you will probably configure also in your own environment. So once you want to start accessing lakeFS, and instead of questioning your repository in general, asking for a specific branch, You'll set up this gateway, and that will let lakeFS answer, okay, give me the files that are on main, on test, on dev, and so on and so forth.
Yep. Yes, thank you. Yeah. So that's what we just did here to get from the my repo and the main branch and the file name. So it's a simple one line CSV file, just one record in there, and to keep it simple. So now my production environment is ready. So I have the main branch, which is production, and the one CSV file here. So just single branch here. So now we are going to, you can, from the API also, you can look into how many branches you currently have, just one single branch. So now I'm going to create a new branch for experimentation purpose, or for a staging environment, or running my ETL job separately without impacting my production data. So I'm going to create a new branch. So if I go back to the UI, yeah, go ahead.
So what actually happens when you create a new branch? Do you copy the data?
So in this case, if you see these two, both the branches have the same commit ID. So when we create the branch, we do a zero copy operation. We don't copy the files. We just copy this commit ID. So both the branch point to the same commit ID, and that commit ID has the existing file structure in there. It can be thousands, millions of files. So when we create the branch, it's a millisecond operation because we are not copying the data. It's just the pointers that we have maintained internally. And in this case, we have just the commit ID. And right now, both the branches point to the same commit ID.
Awesome.
So it's a,
thank you.
Yeah, it's a zero copy operation. So even if you have petabyte of data in your main production branch, when you create a new branch, it's just a millisecond operation. Okay, so now what we are going to do here is run some experimentation or your ETL job in the new branch without impacting the production environment, production branch. So now in my new branch, I have full data set in what you had in production. So I can run my test, anything I want to do in a separate new branch without impacting my production branch, without impacting my production users. So in this case, we are going to partition the data on the first column and write to the new branch. So again, just to reiterate, not impacting the production branch, not impacting the production users. You can run your ETL job or anything you want to do in your separate stage, a separate environment in the separate branch. Now,
so this is my long-running ETL that's running on a separate branch, does everything. If it fails in the middle, I don't care because I didn't do anything to production.
Correct. Yeah, in this case, to keep this simple in the demo, it was a few seconds to run this, but yeah, you can have a separate ETL job. You might call your Airflow DAG to run in a separate on this branch, and then once it succeeds, then only you will promote it to production with high quality data. So let's check the differences between those two branches. So I'm comparing right now my main branch and the new branch. So the other changes happen. Like in this case, we partition the data. So those are the two new files here. And let's commit the changes here. So again, when I commit, I'm committing it to my new branch only. I'm not committing it or merging it to the production. Only I'm committing into this new branch, because sometime you might have long running ETL job. You might run one step of the ETL job, then commit the change, then run another step and commit the change, and so on. So when I go back to the UI here, I can, from the UI also, I can compare different branches. So in this case, you can see all the changes that happened. In this case, this new file was added, which was partition data. So going back here, again, you can compare the same thing from the API, running the diff between the different branches. So now let's say my ETL job finishes in this new branch, which might take hours to run. And then after that, so let's say that if that job succeeds or fails, depending on that, we can make a choice or decision. So if it fails, we don't have to merge these changes into production, or we can just delete the branch. Or let's say if everything succeeds, data looks good, and you run some hooks or actions, everything goes fine, then you can merge the changes into production. So you can do that from the UI. You can compare branch and merge from the UI, or you can do from the code here by using the API. So once it merges, it assigns a new reference ID here. So if I go back and look into my branches here, now you'll see this branch, experiment 1 branch, has deviated from the main production branch. So now it has a new commit ID. So if you see those, it's a different commit ID. But again, we are not copying the data. So let's say if you have millions of files, but you change only 1 or 2 files, or added new 2 files, we are just going to change only those files. We are not going to copy all the rest of the millions of files. But now we got the new commit ID for this branch. Let's continue. So after I merge, so if I run the diff again, now there's no diff because I merged all my changes from the new branch to my main production source branch. And now both branches have the same data set, even though commit ID are different, but the data set is same. So after merging, let's say, so this is also atomic merge. When you merge, let's say you change hundreds of files, thousands of files in your ETL job. So when you merge, everything happens instantaneously. All those files get merged to the main branch immediately. So again, that's again millisecond operation when you merge or staging environment to the main. All the files that change immediately merge to your production branch.
So Amit, 2 questions that we're getting here. I'll answer one and I'll send one your way because I know you're about to present it with the time that we have. So first of all, there is a question about conflicts, managing conflicts. So in generally speaking, lakeFS allows you different conflict resolution strategies. You can decide that the source always wins. You can decide that the destination always wins, or you can decide that in the case of a conflict, you will fail a merge. And you can learn more about that on our docs as well. And another question is, where do the hooks come into play?
Yeah, that's
something that you wanted to show.
Yeah, so I'll show in the demo also. So as you mentioned earlier, there are different types of hooks, like pre-commit, post-commit, pre-branch, pre-create branch, or post-create branch, as well as during the merge, like pre-merge, post-merge. You can call hooks to run some action, and if it fails, you abort the operation, like in this case, for example, merge, and I'll show that. So let me just quickly finish this here. So let's say if you merge the changes into production and something goes wrong, you can revert the changes very easily. So let's say you change thousands of files and merged into production, but something went wrong, and now users are screaming that data looks wrong. Now you can revert the changes in one single command in millisecond operation again. You can just take this commit ID for the merge, or you can go into the UI and look into all the commits which happen in the main branch and get the commit ID. So you can roll back to any of the previous commits. So in this case, we are just going to roll back the recent changes. So I will take this recent commit ID and use this here. And then I'll run the revert command, revert branch. So I'm going to revert this change that happened. Oops, I made a mistake here. So double quotes is missing. Let's run this. So now I reverted back my changes. So if I go back to my main branch here, now my partition data is gone. So when I run the revert command, within millisecond, all the changes that we made in the production branch got reverted quickly. So what we provide is like when you merge, you can automatically promote the high quality data, but if anything goes wrong, you can quickly revert back all the changes. So that's what here in the demo. Next, I'll show how the hooks work. Anything else you want to add either before I switch to the hooks?
No, this is great. So we saw how you can use a staging environment without ever copying the data to run the long-running ETLs and then atomically merge everything once everything is right to production, basically eliminating a risk that if something fails midway in an ETL, it will pollute your production environment. Now, let's say that something didn't fail, but somehow the output of the ETL is not correct. I guess that's what you're going to show in the hooks example.
Yes. So let's switch to my hooks demo. So as Ido mentioned, like different types of hooks are there. So in this demo, I'm going to use a hook for pre-merge operation. So before you merge your data into your production branch, let's say you want to check the quality of the data before merging. And if the quality is not good, or whatever process you want to run for quality check, you can call that. And then if it fails, then the merging will not happen. So what the way the hooks work in lakeFS, you define your hook parameters in a YAML file. So in this case, I'm going to promote only, let's say, Parquet files into production. I'm using CSV file for my stuff, but I don't want to allow to promote CSV file. I only want to allow only Parquet files. So that's where you can just define the name of this hook. And this one is running on the pre-merge on the main branch. And you can define which branches you want to run this hook. So let's say if you create a separate staging branch, you can run the hooks only on the staging branch or ingestion branch. So you can specify which branches to run this hook on. And you can just define the ID, which has to be unique if you have multiple hooks running. And then in this case, I'm using the webhook pointing to a HTTP call. So if you have your own tool for data quality checks, and so you will call it from here, but it has to be a HTTP call. So in this case, I'm running a hooks, a server, a web server on my local laptop here as a container. So I'll just quickly show you here. So this is my hooks web server for testing purpose. And we provide this also as a repo. So if you want to test just the hooks, we provide a web server. But if you already have your own quality check tool, and then you can use that here in the URL. And in this case, we are checking for the format for the files, and only Parquet and Delta Lake files. Delta Lake also has Parquet files, so are allowed. So that's the query parameter to call to this URL. So it can be any query parameters you want to pass in your case. So now we have another notebook, sample notebook. I'll not go into too much detail on this sample notebook. It's a very similar, writing the CSV file to my staging area and then try to merge this into my staging branch into production branch. I'm going to merge this, but I'm using CSV file, which is not allowed as per this hooks here, or the pre-merge check here. So let's run this. It should fail in this case because I'm trying to merge CSV file instead of Parquet file. So here you'll see this message here, which is 412 API exception. And you can see in the message here that hook ran and the Parquet only in production action was run, which is defined here in this YAML file. So let's say now I would like to allow CSV file also. So we can change this YAML file. Let me add that. Let's allow the CSV file also and save this. And now I have to just upload this YAML file into to lakeFS staging area. So let me run this again, this uploading the file, this actions.yaml file to my staging branch, which will be used to run, and then commit that actions file. And now if I try to merge, it should merge fine, because now I'm allowing the CSV file to merge. So that's how kind of hooks work. I don't want to go into too much details on, but we can have a separate discussion if you are interested in looking into how to run the hooks. We have this demo notebook also for hooks.
Hey, Amit, there is a question that's a little bit on the previous thing, which is, where is the Git history kept?
So Git history, like if you, on the lakeFS, where we maintain all the commits here. So all the history is maintained here. All the changes that happen, you can see in the commits.
Yeah, and I think it's important also to call out that the data always stays in place in your buckets. So basically, and I think, Amit, are you done with your demo?
Yeah, with the hooks demo, yes. Yeah.
So let me share my screen kind of to address that question also. This might have been obvious by now, but just in case. So the way that this works is that basically we do copy and write, right? The data sits on top of your buckets, and then every commit in lakeFS is collections to objects and your managed bucket. And then because the object store is immutable, when a new file is created, we do copy and write, and the next commit will point to that. And then you can go and ask lakeFS what files are a part of what commit. And obviously, what this design gives you is scalability and significant savings on storage, right? This performs incredibly well, and this saves a lot on your storage, which kind of talks about the next thing that I was hoping to discuss here. And I'm just watching the clock as well. So the outcome of all of this is that you save a lot on your storage because you don't have to copy environments over and over again in many places. You incredibly increase the efficiency, because now we can do a lot more. We have a lot less problems, a lot less under fire troubleshooting issues. And of course, in the case of an outage, which is honestly, you can't expect everything, but you will always be able to immediately recover. So there's no risk of needing to do this under fire and having a long time with your environment down. And lakeFS is available in open source. You can use this for free. We also have a hosted solution, lakeFS Cloud, which is, by the way, available on AWS or on Azure or on Google Cloud. So all the major cloud providers, we can support you with lakeFS Cloud. And that also gives you like some more advanced enterprise types features, right? Like auto scaling, SAML integration, managed DR, managed garbage collection, SOC 2 compliance, et cetera, et cetera. And we also offer support for lakeFS, and both these offerings are for starting at $2,500 a month, which is, in the world of data engineers, not a very, expensive solution, we'll say it that way. And just as takeaways before we go, we shared a few things here during the call, so I wanted to make sure that you guys have the ability to follow up if you haven't followed up before. One, if you want to get the playground environment and play with lakeFS with our buckets as opposed to your buckets, then you can just use this over here. Two, if you want to look at the notebook example that shows a staging environment like we did in this call, then you can use the webinar samples. And three, we didn't go into many details, but if someone wants to go into more details, we have here the hooks sample as well that you can use in your environment. We are very curious to know if this was helpful for you and if this is something that will be useful for you in your day-to-day activities. So we'll appreciate the feedback if you can answer that question that's appearing on your screen right now. Again, I think that's only if you're on the Zoom link, not necessarily. I know we have a few other streaming services as well, so we'll appreciate your answers. And I like to pause here and see if there's Any additional questions? I'm keeping the Q&A open for a little bit. Okay, did we answer all your questions? Okay, I see more questions coming up. How does it go with streaming ETL?
Yeah, I can answer that. A lot of people use Kafka along with lakeFS or any other streaming product. So we do the ingestion from the Kafka topics, and you can configure it to kind of create a new branch every 5 minutes, let's say every 10 minutes, not doing the branch for each individual streaming event, but a period of streaming events. So let's say I want to create a separate ingestion branch from my Kafka topic every 15 minutes. And then you merge into your main branch. But before you merge, you can run the hooks or do the data quality checks before it gets merged into your main branch. Any other questions?
I think that is it. Thank you, Amit, so much. This was a lot of fun.
Oh,
Appreciate
You're welcome.
you jumping upon. Okay. See you, everyone. Thanks for joining. Thank you for taking the time and learning more about lakeFS. Goodbye.